All right, today I'm going to be going over SBAC Review Day 3. Number 1 talks about cereal boxes. The current cereal box the company has is 12 by 8 by 2, which would look like this. 12 inches high, 8 inches wide, and 2 inches deep. The company wants you to design a new cereal box that has the same volume, it'll hold the same amount of cereal, but it'll use less cardboard. So down here we're going to first give the volume and the surface area of the original box. For volume, we just simply multiply length times width times height, and when we multiply those we should get 192 inches cubed. And for the surface area, we need to find the area of each of the pieces. So you see we have a front and a back that are the exact same, and they are 8 by 12s, so that means that they're each 96. So you have a 96 and a 96. Then you have two sides. This side is a 2 by 12 and this side is a 2 by 12. So those are 24 each. And then you have a top and a bottom that are going to be the same. Those are both going to be 2 by 8s, which would be 16 and 16. If you were to add all that up, it would give you, 272 inches squared. Notice that it's squared because it is area. So now we're going to try to create a new cereal box that holds just as much cereal or more cereal, but use less cardboard. So my recommendation would be to go ahead and maybe make it a little bit deeper, keep the same width, and maybe just a little bit shorter. If I were to do that, my volume would be 3 times 8 times 10, which is 240 inches cubed. So that fits this criteria. We have more volume. Now I have to make sure that the surface area is the same or less. So I need to look at my top and bottom. Those are both 3 by 8s, which is 24. My sides are 10 by 3s, so those are 30 each. And then my front and back are 8 by 10s, so they're 80 each, so 160. If I add all that up, it should come out to 268 inches squared. So I have more volume, less cardboard. Cube-shaped boxes of tissue are shipped to stores in containers. The containers are rectangular prisms. The edge of each tissue box measures 6.5 inches. The dimensions of the shipping container are 19.5 by 39 by 19.5. So I got to figure out how many of these will fit inside of here. So first thing I need to do is figure out how many will fit on that bottom layer. So I got to figure out how many will fit across. If I have, it takes me 6.5 inches for each one of them. I need to take the 39 inches I have and divide them into little 6.5 inch sections. That means I can fit 6 boxes across, and I need to figure out how many boxes wide I can fit. So I'm going to take my 19.5 inches and divide it by 6.5 and find out that I can fit 3 boxes going back. So if I can fit 6 across and 3 back, that means on each layer I'm going to have 18 boxes. Now I got to figure out how many layers. So one layer is going to take up 6.5 inches, 6.5 inches, 6.5 inches. So I'm dividing 19.5 by 6 again. So if I'm going to fit 18 in each layer, and there's 3 layers, I simply can multiply 18 times 3, which means that I can fit 54 boxes into the shipping box. All right. A factory makes 1,200 shirts every 6 hours. 1,200 shirts in 6 hours. The factory makes shirts for 9 hours each workday. Enter the fewest number of workdays the factory will need to make 12,600 shirts. All right, so if I can make 1,200 shirts in 6 hours, I need to find out how many shirts I can make in 9 hours. So I simply can do 9 divided by 6, and it gives me 1.5. That means I took 6 and multiplied it by 1.5 to get 9. So I can take 1,200 and multiply it by 1.5, and that will give me 1,800. And that means I can make 1,800 shirts in 9 hours. And so now it wants to know the fewest number of work days that the factory will need to make 12,600 shirts. Well, this basically just means I can make 1,800 shirts in one day. And I want to know how many days is it going to take me to make 12,600 shirts. So for this one, I could take 12,600 and divide it by 1,800, and that gives me 7. That means they multiplied 1,800 times 7 to get this. So 1 times 7 is this one, so it would be 7 days. Next one. Allison is saving to buy a $500 bicycle by working during summer vacation. The job pays her 8 hours for 1 hour, $8 for 1 hour. Allison works exactly 20 hours each week. 20 hours. How much money is she going to make? 1 times 20 is 20. 8 times 20, 160. So that tells me that I make $160 per 1 week. If she works 4 weeks, so let's figure out how much is she going to make in 4 weeks. 1 times 4, 160 times 4, $640. She's going to make $640 in 4 weeks and buys the bicycle. So she has $640. She buys that $500 bicycle. How much money will she have left? She'll have $140 left. Enter the lowest whole number in the numerator to make the comparison true. So we have some kind of fifth is greater than 1/4. So let's start with 1/5. 4 times 1 is 4. 1 times 5 is 5. This is smaller, this is bigger. 5 is a big number, so that means 1/4 is bigger than 1/5, and that's not what we're looking for. So let's change this to 2/5. Let's see if that's right. 1 times 5 is 5. 4 times 2 is 8. 8 is bigger than 5, so the smallest number I could put here is a 2. Ethan correctly answers 80% of the total questions on his history test. He correctly answers 32 questions. Enter the number of questions on Ethan's history test. All right, so I'm going to take this verbatim and change it to more of like a math sentence. 80% of the questions is 32. 80% of them, that is 32. So I'm going to change this now to what we understand in math. We don't use percents, we always use decimals. So if I change this to a decimal, move the decimal twice, and I end up with 0.8. Of means multiply. Q equals 32. So 8/10, or 0.8, times Q equals 32. This is a multiplication problem. So to get rid of this, I'm going to divide both sides by 0.8, or 8/10. This cancels out and leaves just Q. And now we are left with 32 divided by 0.8, or 8/10, which gives me Q equals 40. David claims if the absolute value of x is greater than the absolute value of y, these bars mean absolute value, so absolute value of x is greater than the absolute value of y, determine whether each set of values for x and y support or does not support David's claim. So let's stick in these absolute values. The absolute value of negative 15 is 15. And the absolute value of 14 is 14. Is 15 greater than 14? Yes, so it supports it. Next one, the absolute value of negative 9/10 is just 9/10. And negative 8/10 would just be 8/10. Is 9/10 greater than 8/10? Yes. And then we have 1/2 greater than 1/3. Yes, that is true too. So we're going to move on to our last question. All right, now we're going to move on to the last problem, 21,900 divided by 25. 25 doesn't go into 2, 25 doesn't go into 21. 25 into 219 goes 8, which is 200. Bring my 0 down. 25 into 190 goes 7, which is 175. subtract, bring my 0 down. 25 into 150 goes 6, which is 150. So my answer is simply 876. See me if you have any questions on these. Thanks.